comparing between EP and another method, Laplace variation bounds, and shows what is the posterior means in each of these and what is the variance of posterior in each of these. In the exact value, the mean between EP and exact is very close, and the variance also is close. This means after your inference, the knowledge of us is similar to exact knowledge, and uncertainty of this knowledge is similar to exact value. We use an approximation in the message passing in the graphical model. In the graphical model between x1 and x2 and function here is blue, we try to split the context as two functions. Q, I said Q left and Q right. It's equal to projection, the probability of x1 if we have x2. And by this splitting, you can pass the message in the graph the splitting of this particle to this, Q left and Q right, and you can approximate this by these two and approximate this by these two. Okay, and if you need to find the Q left is equal to x2 Q right and x up Q left x2, Q left x2, Q right x2, Q left x2, Q left x3, and Q right x3 and Q left x3. Okay, and for finding each of these, you can use this projection of this Q and Q up. And find this value, and if you need to the value here, you can use this to pass the message to another one. And you have a chain in the in your graph. You, for example, in between x1 and x2, you can keep this one and split another one to approximate the value of each factors, and after that, for all of the factor, you can split the value and pass the message. Some result of use EP. Blue, the black one here is exact value in the left side. The blue one is the EP after one iteration, and green one is EP after 3 iteration. 3 iteration means you split all of, you try to calculate all of the factor by splitting another factor. For example, one iteration means you calculate all of the factors by splitting another with this exact mode. And the two graphs, it's a comparison between EP and particle and MCMC. MCMC is show the mean and variance of approximation The green one is MC and red is particle, black is exact, and it is blue. In the right down, you can see the variance of the EP is very similar. It's exact of the variance of the exact knowledge. And in the classification, how we can use this to our classification. If we have 3 points as spam and not spam, for example, 3 email, 2 is spam and 1 is not spam. If we use the perceptual neural network, the blue line is the classified line determined between spam and not spam. In the SPM, we have left and down. It shows the maximum margin between spam and not spam. But in the Bayesian solution, we try to find better. As you can see here, this blue line is better than 2-1 because we don't have any knowledge about the up of the point spam, and we can say is spam or not spam. And this line is shows our knowledge better than another 2 classifier. And in the start part, I said about the projection. Projection use the KLD. KLD formula is I forgot to insert it there. Insert here. But the formula KLD is